To prove that a function f from x to y is surjective, we need to show that for every y in the codomain y, there exists an x in the domain x such that f of x is equal to y. So the usual approach to this is you start with some arbitrary element y or little y here in the codomain, and then you just need to find an element x in the domain such that f of x is equal to y. And since you started with an arbitrary y, you essentially showed that for every y you can find this x, then you're good. I mean, you always, of course, need to verify that the chosen x really belongs to the domain, right? Because you need this property here. And so once this is shown, essentially for every y, you can conclude that f is surjective. So let's see an example. And again, this is the same example we saw for injectivity. So this function here, f of x equal to 2x plus 1, corresponds to this line over here. And notice so that for every input here, so the input is all the real numbers, you get this line here, and that actually makes it so that every element in the codomain, so everyone that I choose in the codomain, if I choose any point, it corresponds, there is some input that gives that output. And so that's the intuition of this function here being surjective. Now, how do we prove this? So again, we need to show that if you were to choose an arbitrary point, let's say y, let's change the color here. So let's say that we choose an arbitrary point y in the codomain. We want to find x in the domain R such that f of x is equal to y. Now, what is f of x? F of x in this case is 2x plus 1, and we want this to equal to y, and if we solve for this, this means that x just needs to be y minus 1 over 2. And so this is some scratch work that you can do to essentially get your candidate. And you need to check, oh, if I take a real number and subtract 1 and divide by 2, okay, I get a real number, so this is actually in the domain, so everything seems to work out. Let's write the proof for this then. So proof. So let y belonging to R be arbitrary. So let's say you take any y. We then choose x equal to y minus 1 over 2. And of course, this belongs to R. So this is in the domain. And now then, with that choice, if you compute f of x, this is going to be equal to f of y minus 1 over 2. And this will be equal to 2 times y minus 1 over 2 plus 1. And let's do it slowly. This will be equal to y minus 1 plus 1, which will be equal to y. Thus, for every y belonging to the real numbers, there exists an x belonging to the real numbers with f of x equal to y. Therefore, by definition, f is surjective. So let's do a quick recap here. So we want to show that f of x equal to 2x plus 1 is surjective. How do we do that? We need to show that that for every element that we choose in the codomain y, there exists some x such that f of x is equal to y. In this case, we're saying, oh, it exists, just take x equal to y minus 1 over 2. And then if you compute f of x, you'll see that it's actually y. And so since this is true for every y, then every y has an input that he is the output of. Okay, very good. Let's look at an example of a non-surjective function. So again, if we look at this function here, this is a parabola, this f of x equal to x squared. And now the idea is that if we look at the codomain here, we want to find, is there an element here that does not have an inverse? So is there an element on this line, because this corresponds to the codomain, that is not the output of any element? And here it's easy to visually see that that's the case. If you take a negative point here, you will see that there is no value of the function that gives you this negative point. The function doesn't pass through it. So we could take, for example, here minus 1, right? And so with that, we can then let's write the proof for this. So consider the element y equal to minus 1 in the codomain R. Then let's do it by contradiction. Suppose, for contradiction, it's always good to announce that you're doing contradiction, that there exists some x in the domain R such that f of x is equal to y. But what is f of x? Then x squared is equal to minus 1, but there is no real number which squared is negative. And so a contradiction. Thus, there does not exist x in the domain such, let me erase this, such that f of x is equal to y. Therefore, f of x is not surjective. So let's recap here. To show that this is not surjective, we need to just show that there exists some point in the codomain that is not the output of any input in the domain. In this case, we chose the point minus 1, and the idea that if minus 1 is the output of something, it would have to be such that x squared is equal to minus 1, where x is a real number, but that doesn't exist. Notice how it's very important that we are dealing exactly with this function here. If you were to change the real numbers with the complex set or so on, you might get a different answer to this, right? So, and this emphasizes again that when you're talking about functions, it's not just given by a formula, but it's also important to understand what is the domain and the codomain of the function. And if you have the same formula, but with different domains and codomains, they're actually different functions. And they might be surjective or injective or any other property, who knows. So always be very precise about what you mean by the function, right? But for this function here, with domain real numbers and codomain real numbers, if you take f of x equal to x squared, this is not surjective.